Hello, welcome back. Today we're going to be starting a new unit about functions. So today we're going to be exploring what is a function. Our objective for today is I will be able to explain the characteristics of a function and its multiple representations. So in words, a function, the definition of a function is a relationship that assigns exactly one output value to each input value. So let's take a look at what that means exactly. So on this table, we have a table right here. We have input and output. And in the definition, once again, it says a function is a relationship that assigns exactly one output value to each input. All right, so let's take a look at this. We have 2 as our input and 5 as our output. Every single time that we plug in 2 to the equation, we are going to get 5 as an output. Same thing with 3. Every single time that we plug 3 into an equation, we're going to get 5 as an output. Every single time that we put 4 into an equation, we're going to get 5 as an output, and so on and so forth. For every input, there is an output. There is only one value, there's only one output for each input. There's only one y for one x. Okay? So, sometimes, a lot of times, we will see these tables written out a different way. So we're going to write it vertically. We're going to write input and output. We're going to learn a different word for them in a minute, but it's our x and y values, right? And we're going to list our input, or our x values. It's 2, 3, 4, 5, 6, okay? And then our output values, which is just simply 5. And now we're going to draw arrows from our input to our output. So what these arrows are saying is that when you put 4 into the equation, you're going to get 5. When you put 5 into the equation, you're going to get 5, and so forth. Okay, this is just illustrating that for each input, it's only going to give you one output. And once again, here is our graph for this function. And I'll show you in a second a trick that you can see to see that this graph, yes, indeed, is a function. So let's take a look at a non-example. So after you write all this down, hit play, and let's take a look at a non-example to help us a little bit clearer to define what a function is. All right, so this is our non-example. We have an input of 1, and we get an output of 1. An input of 2, and an output of 3. Input of 2, and output of 6. Input of 3, and output of 9. An input of 3, and input of 12. Output of 12. Now the definition says for every one output, a relationship that assigns exactly one output value to each input. This is where we run into some issues with this non-example, and this is why it's not a function. Alright, so let's see. This is why it's not a function. Because there are 2 2's that have different values. 2 3's that have different values. 2 in a function cannot equal both 3 and 6. In a function, 3 cannot equal both 9 and 12. That's why it can't be a function. Let's draw the arrows like we did before. Okay, we have 1, 2, and 3 in our input, and 1, 3, 6, 9, 12 in our output. Okay, we can draw 1 to 1, 2 to 3, and this is where our issue comes in. We cannot have 2 arrows going from the same input to 2 different outputs. This is not a function because we cannot have 2 arrows. We can't have 2 outputs for one input. Alright, and then take a look at this graph. Do you see how at the x value of 3, that there are 2 dots above it? We cannot do that with a function. That is not a function. This is a non-example, which means this is not a function. Okay? So, another way that we can write the input or the x value is saying the domain. And the domain is all of the x values in a function. And the range is all of the y values or the outputs in a function. Okay? I mentioned earlier how we can test a point on a graph to see when you look at a graph if it's a function. And it's called the vertical line test. When you draw a vertical line at any point on a graph, if it does not cross that vertical line in more than one place, it's a function. So let's take a look. So here is one function. And you see that I drew two vertical lines on this function. There's no place does it cross more than once. So yes, it is a function. Let's take a look at this one. It's a circle. When I drew the vertical line, you see that it crosses both here and here. Because it crosses in more than one place, that means it is not a function. Let's take a look at it. You can't really see it because I drew the vertical line on top, but you see the red, it goes kind of over, up and down, and then over. You cannot have a straight vertical line. Since there is a vertical line in there, it is not a function. So let's add that. It is not a function, so no. Let's take a look at this one. Change my pen color. Nope, not laser, we want pen. Let's change to yellow. So if you draw at any point vertical lines, I know mine aren't super straight, but at no point does it cross more than once. So because it doesn't cross more than once, yes, it's a function. Let's take a look at this one. If we draw a vertical line, we see that yes, it does cross in more than one place. So that means no, it is not a function. And then here, these are called parabolas, by the way. Here it's a upside down parabola. It does not cross in more than one place when we do the vertical line test. So that means this is a function. Right, so that's just a way that we can check really fast and easy. It's called the vertical line test, whether or not something's a function or not. Alright, so when we have functions, we have something called a function rule. And what the function rule is an equation that describes a function. Alright, so with the linear, which means straight line, so with linear functions or straight line functions, this is what we've been talking about. Slope, or rate of change, or constant of proportionality. All those are function rules. Let's take a look. To encourage recycling, some states require that you pay a nickel for every container that you buy. If you recycle the container, you get that nickel back in those states, all right? So our output or our range would be D for dollars. So D is equal to, and nickel as a fraction is 0.05, and the C is going to be the input or the domain, and instead of dollars, let's fix that right now. Instead of dollars, we want to say number of containers. So sorry about that. Okay, so number of containers. So D is equal to 0.05 C. That's our function rule. So there it is again. And as we do this function rule, we can put it into a table. So as you know, and as we have done this before, and as we use what we have learned before, we can use this equation to fill out this table. So D is the output, C is the input, or the range, okay? So you could put range, domain, domain, and range, okay? So, input, 0.05 times, and we'll do 6. There's 6 containers, equals, how many dollars? 30 cents. Or $0.3, 30 cents. So that's how we got the output. For one input, it only will come out as 0.03 every single time that you do this. Same thing with 12. 0.05 times 12 is equal to 60 cents. Every time that you put 12 into this equation, you're going to get out 60 cents. You could continue this table as we go on and on and on. You can also represent this data as a graph, and you guys know how to do this because this is what, this one is linear equation. We've been working on graphing linear equations. Okay, so your number of containers would be this one right here, your x-axis. My goodness, spelling. Containers, there we go. And this one would be dollars. Okay, and since there's no y-intercept, it starts at the origin, and it's going to be a proportional relationship, a straight line, a linear equation. Right, so that's just a quick introduction to how all of these things connect. So now take a second, you try, determine if each one of these three graphs is a function or not. Use the vertical line test to decide. Okay. And then last but not least, any questions, please write this down. This will not be the only time that we talk about this, though. Don't worry. In class, I want to address any questions that you have, and then we are going to be working through some stuff together and continuing to practice this new skill. So thank you so much for actively listening, taking good notes, and I will see you later.